Jesse Berst, and you're listening to a Smart Grid News webinar. We're discussing how utilities are using cellular today, and we just heard from Jason Ellis and Sunvir Gujral of Qualcomm about the technologies, and we're going to start talking about how that technology is being applied in the real world. First, though, I do want to get to some questions. So the first question here, several people had related questions. Should utilities be thinking of 2G or 3G or 4G, or how soon before 4G modems will be cost-effective for utilities? And Bruce had kind of a follow-on question that several others had as well, which is how can you ensure future compatibility? So there's concerns or questions over technology obsolescence. So Sunvir or Jason, either one?
Yeah, so let me take the first jump at that. So certainly we definitely advocate, based on the network longevity, that 3G or 4G networks are where the network longevity requirements currently are. That doesn't mean that one couldn't get started with a 2G network, being on the 2G network, but we would recommend that you use a 3G or 4G solution, because cellular solutions from Qualcomm have backwards compatibility. So if you deploy a 3G solution from us, then you automatically get 2G as well, whether it's 2G 1X or 2G GSM GPRS. And sometimes in parts of the world, 2G still has very good coverage, and as they start to reform that spectrum for 3G and 4G, but we definitely would like to see people recognize that the network life of 3G is much longer than 2G. And as Sunvir had commented, some of the solutions that we're producing, especially the 8K and 9K solutions, they allow you to develop and even deploy on 3G today. And in the next few years, as LTE prices continue to decline as the products mature and come into subsequent generations, you will see that there will come a point in time where you start to choose to deploy 4G, 3G, 2G solutions as well. And but the engineering development has already been done.
Well, let me jump in here because I want to squeeze at least one or two more questions in. And this comes from Bob, but also from several others. And the basic question was around security and privacy. And what are the security and privacy implications of cellular? Is it easier, harder, more challenging?
Let me take that. I think if the question is asked compared to, say, RF mesh type of network, cellular technologies, at least when you get to 3G and above, is inherently more secure than, first of all, 2G technology than RF mesh as well, because the encryption algorithms and the authentication mechanisms are built into the underlying transport layer of the technology. One of the issues with a RF mesh type of a network is that you have all the data basically jumping from one location to another before it eventually gets back to the utility or to the head end. Now, whereas in Direct Connect, you have every endpoint communicating directly with the head end. So there's a lower likelihood, if the system were to get hacked in the first place, to have entire neighborhoods get compromised. By the way, 3G networks, as far as I know, have never been hacked in terms of being able to spoof information or have unauthorized access to information. On top of that, having the additional processing capability on these 3G modems gives you the ability to add even more encryption layers at the application layer. So you can end up with a very, very secure solution this way.
We all had a question from Judson about, is the business case different for water versus electric? And something that I think might be somewhat related comes from Kent, who wanted to know if Qualcomm's made any advances in batteries and what are some of the typical battery lives.
Yeah, so I'll take this. Clearly, Qualcomm has tremendous activities in battery life, primarily from the mobile devices that we support. But in terms of supporting gas and water meters and other machine-to-machine related sensors that may have an extended period of life of 20 years, there's still some work to be done by the industry that standardizes how we can efficiently communicate information and then tear down from the network as quickly as possible to allow the device to go back into a sleep mode. So we have done some work on this. There's still more work to be done in order to deliver multiple times per day for 20 years of communications. Currently, it is maybe once a day for that type of network life, and it also depends on the type of battery.
Lots more great questions, but in interest of time, I do need to move on. So I want to introduce you to Jeff Norman of SAIC. He's our Vice President of Emerging Technologies, got a couple of decades of experience. Before SAIC, he was an engagement lead with Capgemini, where he also was involved in a lot of real-world installations. And before that, a founding employee for Maine.net. And he's been involved in some of North America's most important cellular deployments. So he's going to bring some of that on-the-ground experience and expertise to us right now. Jeff, thanks again for sitting in.
Well, Jesse, thank you for the opportunity to participate. And Jason and Sunvir, I appreciate it as well as the webinar participants. Thank you for your time. SAIC definitely has a perspective on this afternoon's webinar. You see our registered trademark is from Science to Solutions. We are an engineering-focused company. We do have a critical communications group that supports utilities with RF and network modeling. We do support a full utility lifecycle outside the generating terminal down to the application of energy efficiency, focus on those critical infrastructures issues that face our utility clients. And our emerging technologies group is focused on those technologies that do incorporate communications, energy sensing applications that can help utilities transform how they do business. Throughout the rest of my slides, I'll touch a little bit on the market update. Where do we stand right now? We've made a lot of progress, but we have a long way to go. So what are the decisions that need to be made around applications or architectures? And then what is the role of public carrier and grid modernization today? To date, in the U.S., at the end of 2012, there were approximately 30 million smart meters that have been deployed. There were a total of 50 million smart meters that are under contract. That is representative of a U.S. market that has 130 million total meters combined of electric, gas, and water. We see in Pike Research that they're projecting that there will be upwards of 14 million private field area network nodes that will be deployed by 2020 to support these networks, the majority which will support mesh wireless, towers-based RF with limited power line communications and cellular. So who has deployed smart meters and who have they deployed them to? What I would want you to take away from this slide is that to date in the U.S., approximately 76% of the smart meters have been deployed by investor-owned utilities, and approximately 90% of those were deployed to residential customers. So I think everyone on the webinar is familiar with a smart grid roadmap or with an energy application building block. The point being that we have made a lot of progress with the initial infrastructure deployments with AMI, but we have a lot of applications that we want to layer onto these networks. Is there an opportunity at this point in time to either introduce architectures or technologies that allow us to federate these different energy applications? And by that I mean make them optimal and efficient from a utility standpoint, or do we continue to try to build sole point or single-purpose solutions to address each one of these applications? So as we begin to shift away from the value of smart meters and we discuss applications and architectures, as we discuss with our customers as an industry, do we continue to take a standards-based approach, incorporating those technologies that have been adopted ubiquitously by the consumers, such as cellular and Wi-Fi? Again, we've made a lot of progress in the industry, but what is the role for IP-based communication systems for utilities? Could IP be that common infrastructure that we're looking for to reduce the total cost of ownership? How as an industry do we complement or augment centralized with distributed processing? As we see these periphery devices deployed and the associated data generated, how do we alleviate latency within the networks and the cost of transport associated with this data? And what is the role for edge diagnostics in the industry? Probably everyone on this webinar would agree that one-size communications technology does not fit all, but is there an opportunity for a platform to incorporate multiple technologies? How do we address local data access, or maybe you could refer to it as a messaging bus? Again, how do we federate data across several applications without having to bring it back centrally for decisions to be made. And again, what is the role of distributed processing in the industry? So many times we're asked, what is the role of cellular? Well, where does cellular stand today? Some statistics I'd like for you to take away from this slide are there are 6.3 billion cellular connections globally as of 2012. There were 1.8 billion 3G connections as of Q2 2012, with over or approximately 1 million connections being added today. By 2016, we project there will be 3.4 billion 3G connections globally. There are 89 LTE networks launched in over 45 countries with 280 commitments in 90 countries. From a machine-to-machine perspective, we project that it will go by a factor of 20 over the next 10 years. I was reading in an article yesterday that by 2020, we project there will be 12.5 billion devices incorporating sensors, enabling them to be controlled, monitored, and automated. So why are utilities evaluating public carrier? Again, to echo some of the themes from Jason and Sunvir, the ability to support real-time communications, large coverage, standards-based, affordable cost, highly scalable, and they're reliable and secure. Before I get going on this slide, I do want to take the opportunity to thank several of the participants as I had the opportunity to research for the webinar. In particular, I'd like to thank the folks at AT&T, Consumers Energy, for their willingness to share their experiences to date. I'd also like to thank the folks at Itron that shared their use cases around their adaptive router, around their direct connect metering, all falling underneath the OpenWay platform. We've seen several high-profile smart metering announcements made, in particular by AT&T and Consumers Energy, using public carrier to enable smart metering. We've also seen several announcements around selective metering, where utilities are deciding to spot deploy or to target where they want to enable metering within their footprint, not relying on an infrastructure or leveraging an infrastructure such as public carrier that's already there. We had the opportunity to talk with several utilities that are deploying public carrier or leveraging public carrier for customer energy management, again, providing for an elegant demand-side management or a targeted demand-side management and energy efficiency for their customer base. There are several sensing manufacturers such as Cooper and Tollgrade, GridSentry, that are providing public carrier directly to their midline sensors that are monitoring primary voltage and current as these play into asset management and to outage management. And substation monitoring, again, I'd like to thank the folks at Central Texas Co-op that shared their use case around leveraging public carrier to monitor their SCADA systems with a 6-second pole in their particular SCADA application. And the next slide, I'll talk about communications aggregation. So what is the role of edge diagnostics? Communication nodes enables distributed management. Through white papers and conference presentations, Duke Energy has disclosed how they're leveraging public carrier in their Ohio grid modernization efforts, with over 100,000 communication nodes that are leveraging public carrier for WAN communications to serve as a communications aggregation point, various forms of LAN southbound to those devices that are in and around a distribution transformer, such as smart appliances, electric vehicles, smart meters, legacy meters, streetlight systems, reclosers, capacitor banks, and sensors. This particular device is provided by the mechanical integrator Ambient, has local processing and storage, and has energy sensing applications such as current, voltage, power quality, and power factor. So Jesse, in conclusion, there are several utilities to a man that shared their experiences that have been very positive to date leveraging public carrier, and we look forward to working with Qualcomm and the carriers as industries evaluate what the role is for public carrier in our grid modernization efforts. Thank you.
Thanks very much. You just heard from Jeff Norman from SAIC as part of our webinar on how utilities are using cellular today. And now we're going to finish up with some questions.